All right, greetings YouTube, beautiful mind here. We're continuing chapter 4 on trigonometric functions with section 4.7 Trigonometric Identities. A few objectives. 1, use fundamental trigonometric identities. 2, prove that a given equation is not an identity. 3, verify a trigonometric identity. Okay. So we have some fundamental trigonometric identities, the reciprocal identities. So essentially, like the reciprocal of sine is cosecant and vice versa. The reciprocal of cosine is that's fine. Cosine is the reciprocal of secant and vice versa, and tangent is the reciprocal of cotangent and vice versa. Then we have quotient identities. Tan is sine over cosine, and cotangent is cosine over sine. We have the Pythagorean identities. Sine squared plus cosine squared equals 1. Now, to get to the other two, I usually use algebra. For instance, if I want the next one going down, I'll multiply by what? I'll divide all the terms by sine squared, right? So if we multiply the left side and the right side of the equal sign by 1 over sine squared, that first term, something divided by itself, becomes 1. Cosine squared divided by sine squared is cotangent squared, and 1 over sine squared is cosecant squared. And then it's a similar operation to generate the one on the right. But as far as the Pythagorean identities, I pretty much just use sine squared plus cosine squared equals 1, and then flow from there. Even in odd identities. So the definition of a function being even is when we evaluate f of negative x, we get back f of x. And then the definition of a function being odd, when we evaluate f of negative x, we get negative times f of x, right? So from this is saying that sine is odd. Sine of negative x equals negative sine of x. That's the definition of an odd function. Cosine is an even function, right? Cosine of negative x is going to be the same as cosine of x. Odd also means there's symmetry with respect to the origin. Even means there's symmetry with respect to the y-axis. Okay. Sorry, it's just early in the morning here right now. Anyway, let's keep moving. All right, so in this example, it says that if the cotan of x equals 3 over 4 and theta, what quadrant is that? Quadrant 3 is greater than pi but less than 3 pi over 2, so that's quadrant 3. Find the values of the remaining trigonometric functions. So the plan that we'll do, we'll use cotan of x equals 3 over 4, and then we can use the Pythagorean identities. Let me think, what is that going to give us? Yeah, right? And we'll be able to, we want all the trig identities, okay? And then we'll use the fact that theta is in quadrant 3 to get our signs straight, okay? So again, I'm a fan of, I like to start with the sine squared x plus cosine squared x equals 1, right? Then we can use algebra. If we want cotan, right? Cotan, so tan is sine over cosine. So we want cosine over sine, all right? So I'm going to multiply both sides by, I forgot just that fast, 1 over sine, all right? So long story short, we're going to divide each term by sine squared. So we're going to say this over sine squared, this over sine squared, and this over sine squared. Essentially what we're doing is multiplying the left side and the right side by 1 over sine squared, and then on the left we have to distribute that 1 over sine squared. So now, with that first term, something divided by itself is a 1. Cosine over sine is going to be cotan squared x, and the reciprocal of sine is what? Cosecant squared x, okay? So now if cotan is 3 over 4, all right, so then it's looking like 1 plus 3 over 4 squared equals cosecant squared x. Okay, let's keep working over here. So what is that, a 9 over 16? 25 over 16, right? Because 16 plus 9, yeah, 25, right? So then it looks like we're getting cosecant squared x equals 25 over 16, okay? We can take the square root on both sides. So then if we take the square root, we'll get plus or minus. Let me think about that. We might have to do cases. And I think I'm going to rewrite this. Let me see if this is cosecant. So what is that? That's 1 over sine. So then that means that what? Sine squared x equals 16 over 25. Okay. So it looks like sine of x is, right now I'm going to leave it as plus or minus 4 over 5. Okay. Now, since theta is in quadrant 3 and sine corresponds to our y value, both x and y are negative in quadrant 3, so I am going to just take the negative result there because we're in quadrant 3. If I'm making a mistake, we'll adjust on the back end. Okay. Let me see. So we got sine. Okay. So now since we have sine, if this is our sine, and then we can use like what? Sine squared x. Sine squared plus cosine squared equals 1. So then that's going to be what? 16 over 25 plus cosine squared equals 1. So then cosine squared should equal, so 25 minus 16, 9 over 25. I'll keep working here. So then cosine of x looks like it's a 3 over 5, plus or minus. It should be minus because we're in quadrant 3. A similar argument as before. So now that we have sine and cosine, then I think that we can find the remaining trig functions. Let's see. I might be able to use this space. So our claim is that sine of x equals a negative 4 over 5. Cosine of x equals that. So then based on those two, the tan of x is going to be sine over cosine. So that's going to be what, a 4 over 3. Okay. The reciprocal of sine is cosecant. So that's going to be what, a negative 5 over 4. Reciprocal of cosine is going to be secant. That's going to be a negative 5 over 3. And the reciprocal of tan is cotan, which is what we were given. It should be a 3 over 4. Okay. All right, I think those are good. All right, so now we got those results. We're just going to compare it to our prepared notes. I might shrink this down. I think I will, actually. I'm getting a bunch of stuff I don't want. Okay, just below the 4. Okay, I'm going to have to let me copy, undo. How can I get this? I'm going to delete all of this, undo. Sorry, it's just because I'm running out of space. It's kind of not behaving the way I anticipated. Just give me a moment. How can I get this? Okay, I can get that item. Okay, let's try this again. I'll go like this. I don't want that. I don't want that. I'll take that. I'll take that. Hopefully I dodged. Oh, I thought I got it. That was the main thing I was trying to get. Okay. That one. That. Okay. I'm going to put this here. Now I'll just put this back. Undo. Yeah, this is giving me a hard time. Sorry guys. Let's try this one more time. I came so close with the first one. I want that guy. Got that. I need this. All right, what do we get that time? All right, so what I'll do is just manually move that there. Okay. And then what I'll do is move this out of the way so I can do what I need to do. Now we got it isolated. Yeah, we'll just shrink this down. And then put this back. And then expand this. There we go. Yeah, it just took a little bit of effort. It's a little bit finicky. Okay, and let me do one other thing. I want to copy this result and just so we can put it side by side with the text. Okay. Okay, so let's kind of look and see what the way the book did it. So they just jump straight with the identity. Again, I tend not to commit that to memory. I just use sine squared plus cosine squared equals 1. I do my algebra and convert it into this form. So ultimately, they get that sine was the -4/5. I think we got the same thing. So since cotan is cosine over sine, multiply both sides by that. So cosine, so since we found the -4/5 and we were given the 3/4, then between those two, we can we get that cosine is a -3/5. Okay, so I'll paste, and again, I'll just shrink this down. These are the results that we got, and you can see it side by side. Sine of x was a -4/5. Cosine was a -3/5. Tan was 4/3. Cosecant -5/4. Secant -5/3, and then 3/4. Okay. So and I liked it because I went one way, the book did another way, and you see how we still got the same result. Okay. Let's just try another one. Let's see if we can do another one. So we want to prove that this is not an identity. So we need to show that the left is not necessarily equal to the right. I think the way the book did this one, they just found a counterexample. For it to be an identity, it would have to always be true. So if you find one example that doesn't work, then that's a way to show that it's not an identity. I want to say also, if you expand both sides, the left isn't necessarily equal to the right. But like for instance, if we let x be 0, let's just see what happens there, all right? So then on the left, sine of 0, we're going to get what? 0. Cosine of 0 is 1, all right? The question is, does that equal, okay, sine of 0 is 0, so that's going to be a 0. Cosine of 0 is a 1. 1 squared is a 1, so -1. On the left, -1 squared, that's going to be a +1. Is that equal to -1? No. It's not equal. All right. So I think that's it for that one. We just found a counterexample. Yeah, all you need is one example. For another thing here, like if we expand on the left, on the right we have difference of squares. On the left, we have a squared binomial. When you expand those, they're not going to match up, and you can use that to try to narrow down to try to find your counterexample. Let's see what the text says here. So let x be 0, then sine of 0 equals 0, cosine of 0 is a 1, the left hand side equals 1, the right hand side equals -1. So for x equals 0, the equation's two sides are not equal, so it's not an identity. So again, this is called counterexample to disprove or to show that something's not an identity. Again, we just need like one. I think there's some other techniques there, but for right now, we'll just kind of let that be. To verify that an equation is an identity, transform one side of the equation into the other side by a sequence of steps, each of which produces an identity. The steps involved can be algebraic manipulations or can use known identities. Note that in verifying an identity, we do not just perform the same operation on both sides of the equation. Okay. So we want to verify that this is an identity. We start on the left, and then we want to finish on the right. Okay. So first I'm going to start with a copy of the left-hand side. So we have this what? Cosecant squared x minus 1 over cotan x. I'm just going to start there, okay? And I'm going to expand these guys and put it in the form I'm used to. Now, cosecant is the reciprocal of what? Sine. So it's going to be 1 over sine squared, like this, minus 1 over, and cotan is what? 1 over tan. Tan is what? Sine over cosine. So cotan, I'm going to write it as cosine x over sine of x. Okay. Okay. So let me see. Let's try to clear out the fractions. Will that help us? Okay, so I'm going to multiply by 1 in the form of using the LCD of all the denominators. So if we consider all the denominators here, we got sine versus sine squared. I'm going to multiply by 1 in the form of sine squared over sine squared. I'm just going to try it out and see where it goes. If it doesn't work, we'll adjust. So I'm going to say this times sine squared and this times a sine squared, right? Now let's just do that and see what happens. Is that helping us? That helps there. That one, we're going to have some left over. Okay, instead of multiplying by 1 with a sine squared, instead of sine squared, I'm going to do just sine. Okay, let's try this and see where this goes. Okay. So we would have to distribute here, right? And if we get it to work out, I'll explain why I made that adjustment. This is going to cancel that, all right? So then, let's see what happens. Now, sine divided by sine squared, we're going to be left with 1 over sine x, right? Because one of them cancel and one persists. Minus sine of x over what? Cosine of x. If we multiply by the reciprocal. Okay. Cotan. We're looking for cosine over sine. Okay. What if we get a common denominator? So let's try getting a common denominator with that numerator, right? So it looks like the common denominator on top is going to be sine of x. So that's going to give us a 1 minus. This other guy on the right, we're going to multiply by 1 in the form of sine of x over sine of x. Now I'm pretty sure there's a more direct route. I'm just kind of off the cuff here. Okay, so let's keep going with this. I think this might work. So then we have what? On top, we're going to have a sine squared. Okay, that's going to help us a lot. Both denominators are a sine of x. So now our new denominator is going to become, we got this sine of x. And if we multiply by the reciprocal, we're also going to have this what? Cosine of x. Okay. So now what? We have that sine squared plus cosine squared equals 1. Okay. So if we say what? 1 minus sine squared, we're going to be left with cosine squared. Okay. Okay, so it looks like on top we have cosine squared. And the bottom stays as is. Okay, so this is cosine squared. Okay. Okay, we are pretty much home free, right? Instead of writing it, I mean, this is fine. So then we have cosine times cosine on top, sine times cosine on bottom. So one cosine here cancels one cosine here, and we finish with our desired result. We have cosine over sine, which is the cotan of x. Okay. So a little bit roundabout, but we eventually got there. We just kept applying the trig identities until we got it to condense. Trig identities along with algebraic manipulations, right? Let's see the way the textbook did it. So start with the left-hand side, cosecant squared. Now, I didn't even think of doing that. Pythagorean, right? Cosecant squared minus 1 is cotangent squared. And then, yeah. See, I knew it was something that was more direct. I took a long roundabout way of going about it, but we still got there. The left side of the equation is equal to the right side, so this verifies the identity. Okay, let's see what else we got. So verify this guy. Let me see. Almost. Can we do operations on both sides? Secant is what? 1 over cosine? Okay. I'm tempted to do that. Okay, here. So we have this secant theta minus cosine of theta over the sine of theta. Okay. I'm just going to work on the left and see if I can transform it into the right. So secant is what? 1 over cosine. So I'm just going to get a common denominator for that numerator to condense those guys. So secant is 1 over cosine theta. That's cosine over 1. So I'm going to multiply by 1 right here. I'm going to multiply this by, let me see. We want a denominator. I'm going to multiply by cosine of theta over cosine. So I'm multiplying by 1 in this form. Okay. So then what's going to happen, the top is going to become cosine squared theta. The bottom is going to persist as cosine theta. Now we got our common denominator. And then we still got this guy lingering, sine of theta, right? So now, on top we're going to have 1 minus cosine squared theta. On bottom, we now have, it's cosine theta, just adding fractions, you keep the denominator, and then times sine theta, okay? So then 1 minus cosine squared is going to be what, sine squared? So on top, now we're going to have sine of theta times the sine. It's pretty much the same, similar as we did in the previous, over cosine of theta times the sine of theta. Okay. Something divided by itself, and that leaves us with sine theta over cosine theta, our desired result. Okay, this is just the way we did it. Let's kind of see, let's compare this to the way the textbook did it. Okay, they started with the left side. Secant was 1 over cosine. Okay, so they multiplied by cosine in a similar fashion that we did. So then we would get 1 minus cosine squared over sine cosine theta. You see it here. 1 minus cosine squared over sine theta cosine theta. Sine squared, the sines cancel, and we're here. Okay, I think they did the same thing we did in this instance. All right, let me see. Doing pretty good on time. Let's keep going. All right, we're asked to verify this identity. Okay. I think this might be one where we might need to manipulate both sides. We can try starting with the left and finishing with the right. Let's just start with the left and take it as far as we can. And, let's just start there. But sometimes, you can manipulate the left, manipulate the right, and then I think that works too, but let's give this a go. I'm tempted to use u substitution, like let u be cotan squared. Let's just follow that train of thought. So I'm going to say let u equal cotan squared of x. Right. So if that's the case, then that's going to give us what, u squared plus u, right? That's going to be, again, u squared plus u. Okay. Does that help us? Let's keep going. Okay. So then from here, I'm just going to simplify that or factor it. If we factor out a u, we're going to be left with u plus 1. Okay. Now let's back substitute. Our u is cotan squared x. Okay. So that checks. That's one thing we were looking for. And then we have cotan squared x plus 1. I think that's from the trig identity, right? If we have sine squared x plus cosine squared x equals 1, then if we want it in terms of cotan, we divide by cosine. Nope, we divide by sine. If we divide all terms by sine squared, we'll get 1 plus cotan squared x equals cosecant squared x, right? So we can see here that 1 plus cotan squared is cosecant squared. And so if we account for that substitution, now we'll have cotan squared x times cosecant squared x. And that's the desired result that we wanted there too. Okay, so it's a flow between like algebraic manipulations along with these trig identities. Okay. All right, let's see. Okay, start with the more complicated left side. Now they did, I think the way we did it might be a little bit better. They did cotan to the 4. They broke it into cosine to the 4 for sine to the 4. Okay, let's see what else is going on. So then they got a common denominator of sine. Yeah, that's a little bit more challenging. Once we expanded the cotans. And then if we're going to add those fractions, we need a common denominator. So the least common multiple is going to be sine to the 4. So that middle term, we have to multiply by 1 in the form of sine squared over sine squared. So then we get cosine to the 4 plus cosine squared sine squared all over sine to the 4. We should be able to distribute that sine to the 4 into both equations. Okay, and then cosine squared plus sine squared, let me see. If we factor out a cosine squared, we'll have cosine squared times cosine squared plus sine squared. Cosine squared plus sine squared is a 1. And then we're left with cosine squared over sine squared. And then you can kind of catch it from there. Okay. All right, let's just try another one. Again, just with these, I feel like this might be a little bit intimidating for students. For these videos, just try to absorb what you can and just kind of catch on to like the thought process. It's not until you start practicing. So like if you wanted to get started but you're feeling a little apprehensive, main trig identities we're using is sine squared plus cosine squared equals 1, and then the rest is algebra. It's a lot of algebra that's at play here. So just give it a go. Try to find a few examples to practice. Maybe connect with the tutor or your classmates, or reach out to me for office hours. Okay, let's see what else we got. Okay, here's another way to verify this. I factor the left side. So this is the way we did. Where we did our U substitution, we factored the left side, and then that pretty much got us there quickly. Rewriting expressions using only sines and cosines is not necessarily the quickest way to verify an identity, but it may help if you're stuck. Right, so again, we got lucky with this one. We just factored it and it worked. Oftentimes we'll rewrite everything in terms of sine and cosine, but then sometimes that makes it more challenging, right? So you just try something. If it doesn't work, then you try something else. And you just keep trying until. Okay, let me see. Let's keep moving. So verify the identity. Okay. So now with this one, I am getting a sense, I'm getting this thing about the conjugate, but let me think. Instead of, it's not, I don't think it's really necessarily I mean, we are multiplying by the conjugate, but what I'm going to do is basically get a common denominator. So one denominator is 1 minus, I'm going to just start with the left and finish with the right. One denominator we have is 1 minus sine of x. The other denominator is 1 plus sine of x. So then the common denominator is going to be that left denominator times that right denominator, okay? So what we're going to do, we have this first term, this 1 minus sine of x under 1. And we're going to multiply by 1 in the form of 1 plus sine of x over 1 plus sine of x, okay? And then we still have our minus. This guy, 1 plus sine of x under 1. And to get our common denominator, we're going to multiply this guy by 1 in the form of 1 minus the sine of x. 1 minus the sine of x, okay? Okay. Now if we fool, does that help us? I'm not gonna expand out the denominator, but we definitely should expand the numerator. All right, so it looks like we're gonna have 1 plus the sine of x minus 1 plus the sine of x. The bottom right now, I'm going to leave it as 1 minus the sine. Let me see. Okay. Does that help us? Okay. Yeah, let's do that, right? So with that denominator, we have 1 minus the sine of x times 1 plus the sine of x. So if we FOIL and expand that out, it should become like difference of squares, right? So it should be 1 minus sine squared x, right? It condenses into this, right? And we could check, like, again, this should be difference of squares. If we apply difference of squares to this guy, it should be 1 minus sine of x times 1 plus the sine of x, right? So then, now we have some cancellations and some properties that we can apply, right? So a number plus its opposite adds to 0. A number plus itself is twice that. So, okay, and then 1 minus sine squared should be what? Cosine squared. So it looks like on bottom we have cosine squared x. Okay. On top, it looks like we have are we missing a one somewhere? That's a minus 1 plus sine. Okay. Okay, so looks like it's a 2 times the sine of x. Okay. Cosecant. Double angle formula. Cosine, does that help us? Sine, that's what, tan, but it's not tan squared. Okay, let me go back here. 1 plus sine, that becomes a minus 1 and then a plus sign. So sine plus sine. I think there's a double angle formula. I'm just trying not to look it up. Hang on. This isn't my last one. Let me see. Tan squared. Now, what we could do, if it's giving us a hard time to go from this to the right hand side, we can try manipulating the right hand side, and if we get it down to the same point, then I think that will suffice as well. Let me think about it. Sine over cosine is a tan. Secant. Okay. Let me try manipulating the right-hand side. So I'm just going to put a pin in this. I'm not going to say it's wrong or right. I'm just going to put a pin in it. And then I want to try to work the right-hand side just to see what happens. Oh, where is my pin? This is 21. Okay. So I want to duplicate this. I don't think I can, yeah. So matter of fact, I'm just going to keep that for now, delete that. So again, on the left-hand side, that's where we stopped, okay? So let's try manipulating the right-hand side to see what we can get. Okay, so if we have what? Sine squared x plus cosine squared x equals 1, and we want, say we want tan, sine over cosine, so divide everything by cosine squared. So we'll get tan squared x plus 1 equals secant squared x, right? Divide everything by cosine. The reciprocal is cosine is secant. Okay, so notice on the right-hand side, we have that tan squared plus 1, all right? So then it's a secant squared plus secant squared to give us 2 secant squared, okay. So then tan squared plus 1 is secant squared, so now we have what? Secant squared x plus another secant squared x over cosecant. Okay, I'll keep working over here for right now. Okay. So then it looks like we have a 2 secant squared x over cosecant x. Now I'm going to change things to sine and cosine. Secant is a reciprocal of cosine. So we're going to have 2 over cosine squared x. Cosecant is a reciprocal of sine, so that's going to be a 1 over sine of x. So flip and multiply. Okay. Okay. So then we get what? 2 sine x over cosine squared x, which is the same thing. So we showed that, like, I feel like this is okay. We're going to see the way the textbook did it, but when we simplified the left-hand side, we got it down to, it's really 2 times the tan of x times the secant of x, all right? And we got the same thing when we simplify the right. Double angle formula. Let's just look and see the way the textbook did it, okay? Let's see what they did. So start with the left-hand side, okay, yada, 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 same thing that we got. Okay, so they got it down to 2 sine of x over cosine squared of x. Now try to convert the right-hand side to the same form, which is exactly what we did, all right? Tan squared plus 1 is secant squared, 2 secant squared x over cosecant, right there, right? It gives us 2 sine of x over cosine squared. So then the identity is verified, right? So again, the main takeaway for this example, you know, we were having a hard time going straight from the left to the right. So it was like, okay, let's just start with the left and take it as far as we can. We took it as far as we can take it. Then we put a pin in it. Remember, I was like, let's put a pin in it. So then it was like, okay, let's go to the right and take that one as far as we could take it. And we got it down to the same point. So then that process that basically verifies the identity, okay? Okay, that was an adventure. Let's see, verify this identity. This one, I'm tempted to try the conjugate, all right? So multiplying by 1 here using the conjugate, okay? So if we start on the left, on the bottom we have 1 plus the sine of x. On top we have cosine of x, okay? I'm going to multiply by 1 in the form of 1 minus sine of x on top and bottom, okay? Okay. So on bottom, I think we get what? 1 minus sine squared x on top cosine. Is that helping us? Right now I'm going to leave the top expanded as cosine of x times 1 minus sine of x. So I'm just leaving it for right now. Okay. So then 1 minus sine squared is what? Cosine squared. So the top, I'm going to let it persist for right now. 1 minus the sine of x. Okay. And then that denominator now becomes what? Cosine squared x. Okay. So it looks like we can at least cancel. So we have a cosine is going to cancel 1 down here. Oh, and I think that's exactly what we wanted. On top, we have this 1 minus the sine of x. On bottom, we have cosine of x. And we're Gucci. That was fun. I didn't expect it to go like that. I just, I saw that 1 plus and something was like, well, just try the conjugate. All right, so we multiply by 1 in the form of the conjugate over the conjugate, which you see in blue. And then that numerator, I just left it. I didn't do anything to it. I just left it expanded. That denominator became, is basically the reverse of difference of squares. So we got that 1 minus sine squared on the denominator. And then 1 minus sine squared is cosine squared. Then one of the cosines canceled. And we get this result here. Okay. And if we compare it to the textbook, start with the left-hand side, all right? And it looks like they multiply by the conjugate as well. Okay, and they left that numerator expanded. The denominator, 1 minus sine squared is cosine squared. And then we got our desired result. Okay, we might have 1 or 2 more. So, I think that was it actually. Guidelines for verifying trigonometric identities. Algebraic operations. Review the procedures for combining fractions by finding the least common denominator. Our fundamental trigonometric identities. Review the fundamental trigonometric identities. Look for an opportunity to apply the fundamental trigonometric identities when working on either side of the identity to be verified. Become thoroughly familiar with alternative forms of fundamental identity. Okay. Kind of a mouthful, but so guidelines for verifying trigonometric identities. Start with the more complicated side. If one side of an identity is more complicated than the other side, it's generally helpful to start with the more complicated side and simplify it until it becomes identical to the other side. 2, stay focused on the final expression. While working on one side of the identity, stay focused on your goal of converting it to the form on the other side. 3, option, convert to sine and cosine. So sometimes you're doing manipulations, you get stuck. Try converting things to sine and cosines and then see what you can do there. Writing one side of the identity in terms of sine and cosine often helps. Another option is to work on both sides. Sometimes it's helpful to work separately on both sides of the equation to transform each side to the same equivalent expression. Okay, and I think that's it. Oh, one more. And then another option is use conjugates. So we saw all of these at play over this presentation, right? And expressions containing 1 plus sine, 1 minus sine, 1 plus cosine, and 1 minus cosine, secant plus tan, and so on. It's often helpful to multiply the numerator and denominator by the appropriate conjugate and then use one of the forms of the Pythagorean identities. Sorry. Let me do, where is it? Okay, cancel. And I like to add a page. Okay, I think we're good. Okay, and so with that, we're going to go ahead and end the session here. And for one beautiful mind to another, take care and peace.